All yours.
So today I'm going to be talking about how changes get made to Bitcoin itself and how the protocol evolves and what things we have to look forward to. There's two aspects to this. First of all, there's the ethical aspect of who needs to actually agree to make changes to Bitcoin. So we have to consider Bitcoins are something that everybody owns some of, hopefully. So it's your private property. It's nobody else's business to take them away from you or change the terms that you can spend them. So we have to ask, when we're making a change, is it going to take away someone's Bitcoin, prevent them from spending it somehow? If it does, then we should have their permission before that change gets made. Does it increase the burden on people? Like block size increases are a good example of this. Everybody has to run a full node, so a block size increase increases the capacity that your node needs, your resources, your bandwidth, your CPU, all that. So if it increases what you need to use to actually use Bitcoin, then we should make sure that you're okay with that. And then we also have to consider how it affects people who don't necessarily participate. A lot of the times, the changes to Bitcoin affect everyone equally, so if everybody needs to agree to a change, we really need consensus from everyone to make that change. Whether it's a hard fork or a soft fork really doesn't matter for the ethical concerns. Changes could be implemented either way, most changes at least. But either way, we need agreement from the people that it's going to affect. Does it make sense to exclude people from consensus? Maybe. Maybe sometimes there'll be irrational objections, like someone doesn't really have a reason to object, they're just trying to sabotage the system, make their altcoin seem more useful by making it so that Bitcoin can't do the same things. There's also a question of, should people who don't run their own full node be excluded from consideration? Probably not, but in practice, if they're not enforcing nodes, they may have effectively less say. Besides the ethical considerations, there's technical considerations of what is actually needed for a change to be successful. These are in addition to the ethical considerations. Sometimes the ethical considerations are probably a higher barrier to meet, but other times the technical considerations may be more difficult in practice. So the simplest change to make is on the layer 2. This is essentially between two or more people. They can just agree to do whatever they want. If you want to make a new address format instead of the current Bitcoin addresses, you can do that, as long as the people you transact with are going to accept that address and send to it and all that stuff. So we have some examples. The original layer 2 was actually the peer-to-peer flood network that's still in use, and you actually paid to an IP address. Your node would go out, your wallet would go out and connect to another IP address and get the output to use and send the Bitcoins there. Eventually, that was insecure and not very user-friendly because you'd have to open a port for that to work at all. So Bitcoin address is the longest string starting with a 1 or a 3, or more recently BC1, came about as an alternative to paid IP and eventually superseded paid IP entirely. And that was a layer 2 change. It didn't actually change the protocol, just how people used it. Then there's more recently, there was replaced by a fee where if you're sending a transaction and it's having trouble because the fee isn't enough, you can actually increase the fee. That also is a layer 2 change because it's just a condition that the miner will accept your transaction or a node will relay it. The current work in progress is Lightning, which essentially replaces the flood network with a more complicated system that does the actual movement of value without actually hitting the blockchain at all until you actually need it to. For soft forks is a change to the layer 1 protocol. The useful feature of soft forks is that they are essentially accepted by default. If this change is made and nobody objects to it, you don't strictly have to upgrade, although your node will be less secure if you don't. But if you just keep running the software you're currently running, it will just work. One thing to keep in mind is that it's not enough if nobody upgrades, because the network needs most people to be running full nodes to be secure in the first place. So it's essential that at least a majority of people do actually upgrade to the soft fork code. The harder, technically speaking, kind of upgrade to make is a hard fork. By default, all nodes on the network will reject a hard fork. If you don't actively go upgrade your node, you will, in your economic activity, be opposing the hard fork, even if you've never even given it any thought. This makes it a much more technically difficult barrier to make, because everybody has to be aware of the change. Everybody has to actively participate in making the change. It's essentially, one good way to look at it is you're making an altcoin with an airdrop, and you're proposing that this new altcoin replaces the old Bitcoin. There is a way to make it so that hard forks actually protect the old nodes, because by default, if everybody upgrades and you don't upgrade, not only are you rejecting the hard fork, but you're also left insecure because nobody's mining the old chain anymore. But there is a way to make the hard fork so it protects the old nodes that maybe just got forgotten. And by doing this, nodes have an option to either, they have to update with the hard fork, or they can update to block the hard fork. And that way you have a, still have to make a decision either way, but you can decide you're not vulnerable until you make that decision. Your node isn't rejecting the hard fork, it's just not going along with it, it's not rejecting, you have to decide something to continue. Somewhere in between soft fork and hard fork is this concept of an extension block. It kind of tricks old nodes into thinking they're working when they're really not. Even old wallets will continue working to a limited extent. Most of the time, they're very complicated, and most of the time probably inappropriate to use for most changes. In terms of the technical, what's required to actually deploy them, it's very similar to a soft fork, although we have to pay more attention to what happens to the old nodes that have failed to upgrade. Will their limited functionality and reduced functionality affect anyone harmfully? Essentially, when we talk about getting consensus from everybody using the network, it is not something there is a well-defined solution for. There's been many proposals on how to try to get consensus, but I don't know that there's anything that is, there's nothing that's perfectly reliable. The best we've ever had is situations like in 2013, where Bitcoin essentially stopped working for a while, and that pretty much got everyone's attention to the fact that something had to be done, and that was the only real hard fork in Bitcoin's history. When there isn't consensus, it's usually obvious. So even though we don't have a way to prove that there is consensus, we can usually show that there isn't, because if people don't like an idea, they usually speak up. Even if it's a small minority, they'll be pretty loud about it. So if there's no apparent objection to a proposal for several months, for example, it may make sense to just assume ethically that people have consented to it. assuming everyone is reasonably made aware of it. So when we think about what kind of change to make, we should, we have the different kinds. We have the soft fork, the hard fork, layer 2 changes. There's a number of goals we should think about. We want to minimize disruption. You don't want to necessarily use a hard fork where everyone has to actively participate if you can get away with using a soft fork, where people can just upgrade on their own time frame. You want to maximize the probability of success, which is usually another reason not to use a hard fork, because if people just don't know about it and don't upgrade, they're going to be actually opposing the hard fork. So soft fork is easier because if people aren't aware and they don't really care, they'll still go along with it, and it's more likely to succeed. You want to avoid complexity and technical debt, which is essentially long-term complexity to the code that has to remain even after the change is completed. Obviously, you don't want to just say, oh, everyone just use Mt. Gox, just keep your Bitcoins there and transact on Mt. Gox. That just puts a lot of trust in Mt. Gox and compromises the decentralized security. That is kind of the point. So when we put all these goals together, usually it comes out to preferring layer 2. If you can't do it on layer 2, then you want to soft fork it. If you can't do it a soft fork, soft hard fork, and finally extension block in a few extreme cases. So for example, the lock times that are on Bitcoin transactions, they're inherently based on the blockchain because they work on the block height and the block timestamps. So they can't, it's not something you can do in layer 2. That's why check sequence verify, check lock time verify, all that has to be done as a change to the consensus protocol as a soft fork. Confidential transactions is a proposal that's someone's been working on for a while, a few different people actually. It fundamentally changes the consensus logic because the UTXOs have amounts and confidential transactions hides the amounts. So it's not something you can really do with the soft fork because old nodes won't know how to verify that the transactions are spending less than they're consuming. So that's something that would have to be a hard fork. You could do a block size increase with an extension block, but the complexity is really probably not worth it. It's probably a lot better idea when there's consensus for that to just go ahead and do a hard fork or soft hard fork for that. On the other hand, something like Mimblewimble is fundamentally different at the conceptual level. You don't have UTXOs at all. I believe it's accounts or something like that. I mean, another example would be an Ethereum-based system like Rootstock. If you were to put that in the main chain, you would probably want to do it as an extension block instead of trying to make it all part of the same block because it's fundamentally different in how it works. The process of actually making these changes, first we have to get the community on board. We have to give this idea to the community, make sure people are generally in agreement that it's a good idea. Once we have that, then we work on a specific implementation, a solution, get the developer team to agree that that's a good way to do it, not just one developer team, but all of the developers. That includes the method of deploying it, which for soft fork in the past we've done just based on times, we've done it based on miner signaling. There's a lot of pros and cons to different methods. I'm not sure what the next one's going to use at this point. The last one used BIP9, which didn't work out very well. The next step is to write a draft Bitcoin improvement proposal and get it implemented and reviewed by the developers of each implementation. This is the formal specification, the code actually implementing the change. So it's pretty important to make sure it gets well reviewed, well tested, so that there's no surprises when it gets deployed. Finally, we go back to the community. We measure the community support for the final proposal that's got all the technical specifications laid out. And we want to make sure it's not going to fail deployment, because then we have a big disaster on our hands. Once we're pretty confident that the community is going to deploy this change, then it gets merged to the implementations of all the node software. We have to make sure it's backported to old versions, especially in the case of hard forks, so that people who aren't updated to the latest version can still continue using Bitcoin without being coerced to upgrade. Obviously, there's limits to that. Very old versions aren't maintained anymore. There's not much anyone can do about that. I mean, if someone really needs an old version, they can maintain it themselves or pay someone to maintain it. And then finally, once all that's done, we can actually deploy it using whatever deployment mechanism is agreed on. An important factor to deployment is that the new versions of the software that actually implement it need to be very clear in the release notes that it has this changed consensus rules, because if it doesn't, people can't make a informed decision. If you don't put in the release notes at all, and people are tricked into upgrading, which is not a good thing. The point of Bitcoin isn't to just blindly trust the developers. So it's important that people make a aware decision. They're not just being tricked into running change. Some possible updates that are in the pipeline at varying stages is SegWit v1, which is as opposed to SegWit v0 that was deployed last year. This is cleanup, extending the script. Simpler signatures. Right now, all the signatures are 73 bytes. It's pretty trivial to make them 64 bytes instead. You can also, one thing that I'd like to get in there is the ability to run some extra conditions when you're signing instead of before you give someone an address. Right now, to have any conditions, you have to make it part of the address up front. So, but basically trivial, small changes that would probably have been a good idea to put in SegWit initially, but it was already a lot up front, so we wanted to keep it simple. Lightning is, probably everyone knows about Lightning. It does real peer-to-peer transactions instead of just flooding the whole network with every transaction. It uses a lot less blockchain space, and the transactions can confirm instantly. That's a layer 2 change, so it doesn't need any more consensus changes at this point. Just a matter of implementation testing and people adopting it. Signature aggregation is this idea that when the miners are producing a block, they can take all of the signatures of every transaction in the block and ideally combine all those signatures into one. I don't think there's a cryptographic way to do that that's been discovered yet, but there are middle layers where if you're doing a coin join with a bunch of people, you can combine all of your signatures in that group. So it's something that gets the blockchain space usage down, has the potential to go even further in the future. Confidential transactions I mentioned earlier, it hides the amounts of the transactions. I don't know if that's enough privacy right now. It increases the block space used for the transactions. It's something people have been working on, making it use less space. It's yet to be seen whether that will be sufficient or whether it will be deemed useful enough to deploy. We have the idea of decentralized sidechains, which allow you to basically make your own consensus protocol and use real Bitcoins on a separate blockchain. This is a pretty old idea now, but with mining centralization, it really hasn't been secure to deploy. But maybe in the future, if mining is more decentralized, then it becomes an option again. It's mainly for testing more than anything, however. Blockstream a few months ago announced Simplicity, which is an entirely new script language for smart contracts. It has similar flexibility to Turing complete, but it's not literally Turing complete, even though it can do all the same things. So it's pretty interesting. A soft fork that I think we really need to do at this point is reducing the block weight and the block size limit. This is because the initial sync time right now, can take a very long time, and with the current 2 megabyte, 1 to 2 megabyte blocks that we're seeing, it just continues to go up faster than technology can adapt to make it simpler. So this is a barrier for people to adopt Bitcoin. They won't be able to start their own full node, or they won't want to wait however many weeks for it to sync. A lot of people talk about increasing the block size, but with some of these other improvements, especially Lightning, hopefully the block size we need will be a lot less, and it may be more palatable to actually reduce the block size, at least in the short term. Any questions?
Yes, Brain OS / John Capek. Can I re-say the...
Well, that gets into whether you...
Yes, sorry. So it was like a reflection, like a question and some concerns. He was asking about confidential transactions and regular transactions. They will survive both in the same Bitcoin software, yes. And his suggestion was that if we keep both, eventually the governments or institutions could say, why did you move your coins in the confidential way and not in the open way? So his question is, look, do you think we should go straight to a full confidential transaction method, or combine both in the same network? Yeah, sort of?
Going to the ethical aspect, you can't really force people to use confidential transactions because it's their property, it's their decision whether they want to adopt the change or not, whether they want to use the confidential transactions. I understand your point that it makes confidential transactions less private if people don't use them, so for that reason it would make sense for the community to freely choose to use confidential transactions by default, every case they can, and only maybe use the legacy ones when they're moving their coins that they had from before the fork. You obviously can't force people to do that, but if it's good for the community, hopefully a majority of the network will move, and a majority should really be enough for that, as long as it's by default, essentially.
Well, one more question, and then I'll ask Luke here, yes? Would you care to do an open Q&A tomorrow during lunch?
Okay.
Yeah. So we will do an open Q&A tomorrow during the lunch. This last question, please.
Yes, so in terms of privacy, which are the other developments you think are suitable for this purpose, to increase privacy? And what is the likelihood of these features being implemented in the next year or in 2 years?
There's zero knowledge proofs. I believe there's some issues with trusting the trusted setup on those. I'm not sure if there may be a combination that doesn't require the trusted setup, but if it's opt-in, you could potentially use that, but then there's the question of can it be used by default if it uses a trusted setup. Already usable today is CoinJoin, where a bunch of people get together and they make their transactions together you don't know whose inputs are whose and whose outputs are whose, unless you're a participant to the coin join. So that's very useful for privacy, depending on what you need. I mean, obviously, someone can look at it and say there's a 20% chance that this person sent to that person, but if you just want to be so that nobody can say with 100% confidence, that's maybe good enough.
Okay. Look, thank you. Yeah, it's an honor to have you here. I have some questions for you tomorrow. That's why I wanted you to come back.